doing. Okay. But a lot of you will see that if you learn how to check over better, you're going to get better marks too. Okay. So today, for the first time, we are doing equations. Now, equations have an equal sign. Okay, so now they're going to equal something. If they equal something, means we could solve them. If you go look back on all of your quizzes that you just did, the answer's like 6a minus b, 6a plus b. Well, what are a and b? Well, we'll never know unless they have an equal sign. So today's the first day they have an equal sign. So the rules change a little bit. And when the rules change a little bit, they get conflicted with all the other rules we know. That's why you start doing a study sheet and you go, okay, equations, now they have equal signs. Okay? New rules. Okay? And then you see the old rules next to the new rules, and that's how you keep things straight. And you write little things. You know, make sure when you're just solving, quadratics, you do this. But if it's an equation, make sure you do this. Okay? That's good math. Not the 1 plus 1 equals 2 math. It's the keeping all those ideas straight. Now, we're going to be talking about the zero product law. So we're going to start with just this. Do you see this statement here? X minus 3 equals 0. What do you think X would be? 3. Now, can everyone just look at that and see 3? Because 3 minus 3 is 0, right? That's the 0. That's not the zero product law, though. Now, say you're like, what? 3? I'm not seeing it. Okay? Well, you could do it algebraically. X minus 3 equals 0. Add 3, right? Because we're going to solve for x. X equals 3. Okay? So you can actually solve it. Now, why is that kind of good? Well, what if I said, I'll give you this example. 2x plus 3 equals 0. What's x? 3 over 2? Negative 3 over 2? Okay. Does everybody see what would be negative 3 over 2? Maybe some people don't see that. So, if you can't see it, spend the 30 seconds and just do some math. 2x would equal negative 3, and then I divide by 2. X would equal negative 3 over 2. Okay? So if you're not good at just inspection, which, hey, that's cool. If you're not good at that, just put something in place for you since you're not good at that. I mean, probably the greatest thing about growing up is two things. Figuring out what you're good at, your strengths, but also figure out your weaknesses. Okay? And, hey, we can work on our weaknesses. We can keep fostering our strengths, whatever. But make the learning adapt to you instead of you always adapting to the learning. Now, how about x plus 1 equals 0? What would x have to be to make this true? Negative 1. Now, if I had x minus 3 times x plus 1 equals 0, what would make this true? 3? But then I've got 3 plus 1. I've got 4 in there. If you had a billion things and you multiply it by 0, you got nothing. And this messes with some people because they're like, what? That doesn't make sense, okay? Well, it kind of does. Because if I put a 3 in here and a 3 in there, because let's say x equals 3. This is going to be 0 times 4. Does that equal 0? Yep. So when you're multiplying things, like say there's this long equation, and it was like 2 times 3 times 8 times 6 times 41 times 9 times 3 times 2 times 0. Okay? Do you see how much time you're going to waste if you don't know the zero product law? The answer to that is 0 because one of them is 0. Okay? So that's kind of why it is important to read the question first before you actually start it. Because you'd save yourself amount of time. Okay? Now, so we know 3 would make this equal 0. And what else would make this equal 0? Not half, no. Negative 1. Because if you put a negative 1 into both those, you're going to get 0. Okay? In the next one, what would be the x's that would make that equal 0? If x is 0 or negative 1. Good, thank you. Okay, because if you put a 0 in here, I don't care what's beside it. I mean, if there's a dog beside it, 0 times the dog will be 0. Okay? If you have negative 1 here, I don't care what this is, it's gone. Because negative 1, 1, 0, whatever times 0. So this is called the zero product law. In a product, if there's at least one factor that equals 0, the entire thing equals 0. Now, this is a pretty simple concept, but pretty important. Okay? And you know what's really sweet about this one? Your calculator has a nice way of just giving you the answers. Okay? And I'll get to that in a little bit. Let's try and actually do it without the calculator first. Okay, so let's just turn the page. And let's go right down to this example. Now, do you see that x squared minus 9x plus 20 equals 0? And it says, well, find what x is that makes it equal 0. That's called the zeros. Finding the solution is the same thing as finding the zeros. Now, zeros aren't the round things anymore. Zeros are the things that make it equal 0. Okay? So in the last one, 3 was a 0 and negative 1 was a 0. Now, you're going, no, 0 is a 0. Okay? But when we're talking about zeros, we are talking about the things that make the equation equal 0. Okay? Now, see, just x squared minus 9x plus 20, you're like, I don't know. Like, what do I guess and test? No, you factor it. Okay? You may remember this. It's what two things add to negative 9, what two things add to 20. What would I be looking for signs? Good. What would I be looking for numbers? 5 and 4. X minus 5, x minus 4. So what would be the zeros? What are the zeros? Let's just write it over here. The zeros are 5 and 4. Okay. Now, I'm doing a test. I got that. I'm like, pretty sure I got it right. What if I'm having a bad day? What if I didn't read it right? What if I did something wrong? So you can do this. You can just watch this. You don't have to do it. But if I take the question, x squared minus 9x plus 20, and in y2 I'm always going to put 0. Because when y equals 0, that's the x-axis. And then you get this graph here. Okay? Can you see this? Okay, so there it is. Now, can you see, just by looking at it, that 4 and 5 are the zeros? It's where it goes through the x-axis. That's your answer. 4 and 5. But say you're looking at it and you're like, I don't know if that's a 4. That could be like 4.1. Who knows? So you go like this. You hit second, trace, and we're going to do intersection. Well, intersection, what are you talking about? Do you remember how I put y2 is 0? So I'm going to find, and you can't see it there because it's along the line, but there's a line there. Now, so I get the spider by the first one. I just hit enter 3 times. The spider tells me that x equals 4. Okay, then I do it again. 5. Okay, now get away from that other one or else it just goes back to it. Okay, it's a pretty lazy spider. It's going to go to the closest 0. So get it, so that is the closest 0. And it tells me my other one. Okay? Now, why is that sweet? Well, I think that's a little obvious. And it is something to make sure that written response is right. And you know what? Don't be all like, oh, I don't want them to know I used my calculator on this one. If I did all the work, I would actually also just draw the graph right beside, checked. These were the x-intercepts. Because x-intercepts are the same thing as zeros, is the same thing as the solution. Okay? Can you remember that? Okay? Now, let's just do, like, let's do A and C here. Now, what's x squared minus 81? What's that saying to me? Difference of squares. So this would be, what would it be? X minus 9, x plus 9 equals 0. So what are the zeros? What are the x's that makes this thing equal 0? So plus or minus 9, right? And if you were to graph this, you will see it'll go through negative 9 and positive 9. Okay, how about C? What are difference of squares? We're not going to divide it by 10x. We will factor out 10x. If I factor out 10x, that would leave me with x minus 9. Right? Yeah? Maybe? Okay. So therefore, what are my zeros? What would make this thing equal 0? So x equals 0 or 9. That makes sense? And if you were to graph this, you'll find it'll go through 0 and 9. Okay. Let's make it a little bit harder. Let's just do, maybe I'm going to do one like that one. So I'm going to do A. You guys with me here? Okay. This one. Why is it different than all the rest? It's a type 2. What's a type 2? A type 2, to me, that's kind of something I just called it. Type 1 is if there's nothing in front. Type 2, we got to do this one a little different than the other ones. Okay? So I've got to go, what two things add to give me negative 13 and multiply to give me negative 30? Now, what would the signs be? Huh? No, what would the signs be? Not double negative. Negative and a positive. And this one gets more people get this one wrong because you know what they're thinking? Negative 3, negative 10. Like it's just like so easy. This is sweet. They do it and they get it wrong. And I go, how does negative 3 times negative 10 equal negative 30? And they think about it for a while and I'm pretty sure, oh, right. So doing the signs first stops people from putting negative 3 and negative 10 because there can't be two negatives, right? So then we got negative 15 and 2. Okay? So, remember, I just can't go x minus x minus. This is the one where I've got to go 3x squared minus 15x plus 2x minus 10. Make sure these equal that. Yeah, good. Equals 0. Okay? And hopefully these are getting routine at this point in time. So I put a set here, a set of brackets there. What can I take out of the first set? Leaving me with x minus 5. Next set, leaving me with x minus 5. Okay, so my two solutions are, my factors are x minus 2 and 3x plus, it's x minus 5, sorry, and 3x plus 2. Okay, the first x is pretty easy to find. What would it be? Okay, so x equals 5, And the other one would be, again, if we suck at these, we just go like this. 3x plus 2 equals 0 minus 2 minus 2. 3x equals negative 2. At this stage, you should know it's negative 2/3. But if you really want to keep going, do that. And I would recommend doing this anyway. It's not like you got to do 50 of them on a test. Okay? Maybe you're going to be a bit lazier on homework. But what do you got to lose, right? On a test, you get to lose a mark. So 5 and negative 2/3. And again, if you graph that, you would see it would go through negative 2/3 and 5. Okay. So let's do a word problem and see how these things actually help us solve stuff. Okay, because that's truly and we could do max and min problems, and you know, there's not just like what are the dimensions, but like if I gave you so much fence, what would be the maximum you could build? And everyone's like, oh, a square. Okay, what if one side is the side of a barn? So how would you do the other sides, right? Another question you could do the max min is, okay, you own a gym, right? And you're charging $35 a month membership. Every time you increase your membership prices, you lose some members. What would be the sweet spot? What should you charge your members so you get the maximum amount of money? And there's people that are paid big, big, big money to do this, right? If you ever do any looking into Walmart, like Walmart, they're like savages when it comes to their prices. And what I mean is, like, if say you're making a DVD player for them, okay, so you're like, whatever, Samsung, you're making a DVD player, they actually come into your, part of it is, like, if you want to be into Walmart, we have to be involved. So they will go in there and they'll tell you how to take 3 cents off that thing. Okay? Now, 3 cents to you when you're buying it, maybe that's not a big deal. But it is to Walmart when they are selling thousands of them, and then they do this to every product. So Walmart has to find that sweet spot too, because they don't want to jeopardize quality. Okay? And you may think of Walmart, oh, like, yeah, that's all cheap stuff there, and it's not true. Walmart does what it thinks is the best price, the best value. And the best value is done through this process here. Okay? And we're going to learn that through max and min problems and stuff like that. Today we're just going to be looking for exact answers. Okay, so you got a rectangular sheet of paper, and it's 300 centimeters squared. Now those people that are visual learners, there you go. Rectangular piece of paper. Yeah? Okay. Now, what is the area of this? 300 centimeters squared. Now it says find the length and width if the length is 5 centimeters more than the width. Okay? Now, you know how length and width can always be interchanged? But I, in my head, always think of the length as longer than the width. Okay? That's how I think. And really, it's not true. Okay? You can have your length smaller than your width. It's just how I think. So I would immediately go like this. And since I'm the one writing the notes, we'll do it my way. Okay? Now, which one would you call x? Length? Okay. Because it wouldn't make sense to do this, would it? Because wouldn't we expect the longer one to be the plus 5? Yeah? But, would this make sense? Is this, the length is 5 meters more than the width? Yeah. Now, I'm just throwing this out there. I would never do it this way. Okay? How do I think? This is how I would think to do this question. It just makes more sense. Like you're putting the more with the longer one. And it was that way too before. It's just x minus 5. And yeah, okay, I get it. I know what you're doing, but it's kind of weird. Okay? But this would probably be the most simple way to do this, right? Which is kind of our goal. You don't want to be your worst enemy when you're doing a test and make it harder for yourself than it needs to be. Okay? So, and it's always good to know a formula. And if it's any formula that any student will tell you, it is length times width equals area. Okay? Ask any like elementary kid, what's the formula for this? Find the area of this. He always says length times width. Doesn't matter if it's an ice cream cone or whatever. It's always length times width, right? Well, there's pi r squared too. No, length times width. That's the only one they know, right? So everyone learns this one, length times width. So let's do it. That is x times x plus, oops, it'd be x plus 5, would it not be? X plus 5 times x equals 300. Okay? Now, usually we put the x in the front, but I was doing length times width. But this would be x squared plus 5x equals 300. Now, something's weird here. Like, I get it, we're doing problems now. But how does that even relate to the stuff we did 5 minutes ago? Because all the stuff we were doing 5 minutes ago equaled 0. So how do I fit this one in the lesson so it's... I would actually subtract 300 to both sides. And now I do have it equaling 0. Okay? And now if I find the zeros, I will find the answer. So I'm going to use some factoring. Factoring would be what plus what equals 5. And what times what is negative 300. Okay? Now, if it's negative 300 and a positive 5, what would my signs be? Pardon? Positive and negative, right? And whatever these two numbers are, they're going to differ by 5. But they must multiply to be 300. What would those numbers be? Positive 20 and negative 15. So, now don't go from here to finding your answers. What happens right now is people say that x equals 20 or x equals negative 15. And it's not true. I still have to make my equation, or my... So what does x equal? What does x equal? Huh? Negative 20 and positive 15. Now, do you understand why negative 20, even though it's mathematically correct, if I put negative 20 into there, I will get the answer 300. That is mathematically correct, or theoretically correct. But in real life situation, can I have negative 20 as one of my dimensions? No. So the negative 1 automatically goes away because you can't have negative dimensions. So just no negative dimensions, right? So it's gone. So now x equals 15. So all I do is I put 15 in there and there. So what are my dimensions? What does my width equals? 15. Length equals 15 plus 5, which equals 20. Now, anyone read the question? What are they actually asking for? Perimeter. So I'm pretty close at this point. Haven't answered the question yet, though. So what is the formula for perimeter? 2L plus 2W. So P equals 2 times 20 plus 2 times 15. So actually the perimeter equals 70 centimeters. Okay. So it's going to be a good day for you. Finish the notes. I want you to 1 to 3 odds. And 4, 5, and 7. Okay, it's a beautiful Friday. It's going to be an awesome weekend. Leave the math behind and get it done here. The last 10 minutes, we'll get that test back, see how you did. Just don't waste this time. Especially those people that have busy weekends, they need this time.